In this video, we're going to review what we did in class regarding the probability distribution and how we find those values and using the binomial formula. So if you recall, we were using an example of 5 births, 5 women or one family with 5 babies. Somehow we were having 5 births. And we were talking about the probability of having a girl, as in this particular case, being a success. So instead of writing it this way, probability of a girl, for binomials we use the small case letter p, and that just represents the probability of a success. Okay. And we're assuming that in this case, 2 outcomes, a boy or a girl. So the probability of a girl is 1/2. And today I'm going to write it as 0.5 rather than a half like we did in class, 0.5. Okay, therefore we know that the probability of a boy or not a girl is going to also equal 1/2 or 0.5, which we're going to call it 0.5 today. All right, in this case, we don't write it as probability of B. We write it as a small case q, and that probability is 0.5, and this is what we call a failure. And that's one of the requirements that must be met in order for it to be a binomial. You have only 2 possible outcomes, and we refer to those outcomes as a probability or success. And because there are only 2 outcomes, we therefore know that P plus Q must always equal 1. It's basically a success and a failure are complements. All right, then we took it to the next step and we created a binomial distribution, or probability distribution, I should call it. And in this case, x is our discrete random variable. That's just a fancy word for saying x is our number of successes. It's our number of successes. So for this particular problem, it means the number of girls in those 5 births. Sorry, my mousing is so writing. My pen is difficult here today. So what is one of the possibilities? In each case, we're going to have all 5 babies. One of the possible outcomes would be to have all boys, all 5 are boys, in which case this is a 0. That means 0 girls. That's one of the outcomes, 0 girls and 5 boys. Another outcome is we could have 1 girl and 4 boys. We could have 2 girls and 3 boys. We could have 3 girls and 2 boys. We could have 4 girls and 1 boy. We could have 5 girls. And these are all the possible outcomes. There are no other options in this particular case of 5 births. All right. So then the question becomes, how do we find these probabilities? How do we find these probabilities? And we should know, because there are only 5 possible outcomes, these probabilities in this column of these 6 outcomes, possible outcomes, their total probabilities have to add up to 1, 100%. If it does not add up to 1, you don't have a probability distribution. Okay, so there's 2 requirements. The 2 possible outcomes and the sum of the probabilities has got to equal 1. All right, so let's go over to the side here and we'll figure out how we do this. How do you find each of these probabilities? Well, I'm not going to go through every one. I'm just going to pick one for an example because we do the same thing every time, and it is a little time consuming. So we're going to go through the method and then we're going to learn how to use technology. So if you recall, the probability formula, the probability binomial formula goes something like this. The probability that x equals whatever number you want over here, one of those 6, we'll call that little x, is going to equal n choose x p to the power times p to the power of x times q to the power of n minus x. It's a big formula, looks fancy and overwhelming, but it's using all the concepts that we have learned in probability in chapter 4. So let's do number 2 here together. What is the probability that for this particular problem x will equal 2? What's the probability of having 2 girls and therefore 3 boys? Well, let me write this over here. So What is the probability of 2 girls and 3 boys? Well, because this is 5 events happening, we know we're going to be multiplying these 5 probabilities together. And we know that the probability of the girls is 0.5, and we've got 2 of them, so we're going to square that. And we know we've got 3 boys, and that's also 0.5, but we're going to break it up. And that's going to be cubed. We've got 0.5 times 0.5 times 0.5 times 0.5 times 0.5. Those are the probabilities of each thing, and we're multiplying them together because it's and. We have to think of it like 5 events. But then the second part of this is that we have to consider all the different ways we can arrange this. How many different ways can you have 2 girls and 3 boys? Well, if you remember from what we were doing in class, for example, this is one arrangement. You could have 2 girls and then 3 boys. Or you could have a boy and a girl and a boy and a girl and then another boy. So there's lots of different ways. In fact, how many ways? Question mark. Well, if you recall, the way we did this in class is you've got 1, 2, 3, 4, 5. 5 events, 5 factorial. But then we had to divide through by that double up. We have 2 girls, so we've got to divide by 2 factorial, and we have 3 B's, so we've got to divide through by that 3 factorial. And this is simply the formula for 5 choose 2, or 5 choose 3, whichever, but in this case. So that's where the formula is coming from. In this particular case, it's going to be 5 choose 2. By the way, this n, that's your number of events. In this case, this is n. This is your P, and this is your Q. So you do need those 3 values. So putting 5 in for n, choose 2. That's all your different ways of arranging the 2 girls and the 3 boys. Times the probability of P, or P is just your probability of having a girl. That's that 0.5. And it's to the power of 2 because we're having 2 girls. And then it's 0.5 to the power of 3 because that's your 3 boys. And there you go. That's the probability binomial formula. And it looks complicated, but it really is just those probabilities that we learned in class. If you punch that into your calculator, and be careful, if you're having trouble, you can let me know, but you will come out on your calculator with a 0.3125. So approximately 31% of the time, this is the outcome you'll get. In 5 births, you will have 2 girls and 3 boys. There's a 31% chance of that. All right, and if you could go on and do the binomial formula again. So for example, if we just take a look at this one here. I'm not going to do the whole thing, but what would be the formula to find this out? It would be x is 5, n is 5. So it would be 5 choose 5. Then you'd have p, which is 0.5, to the power of x, which is 5, times 0.5, which is q, to the power of 5 minus 5, which is just a 0. You can plug that into your formula. So it's the same formula over and over and again. It's just your n's and your x's, or your n always stays the same. Your x changes based on what this value is right here. Okay, and whatever this worked out to be, I believe it's a 0.03 something. If you added up all these sums, it will in fact equal 1. Okay. All right, how do we use some of this to help us solve problems? Let me turn this off here, and let's open this one up. This is a binomial formula, a binomial distribution, probability distribution that we are actually given in one of the homework number 13 problems. This is covering. Get myself a pen here. So we are now looking at problems in homework number 13. Let's close this off and let's go to layer 1. Here we go. Let's try this again. Homework number 13 is where I'm at. All right. And so we're just going to try to make use of some of the things we've just been learning in the earlier part of this video. So here we are given the probability distribution, and in this case, we're taking groups of 5 people who are trying a drug. This is a drug trial. And they are asked if they have a headache after using the drug. So in groups of 5, these are all the possible outcomes. So is this a binomial distribution? So are all the criteria met for a binomial distribution? First of all, one of the things we have to have is a fixed number of trials. Fixed number of trials. And in this case, yes, we have a fixed number of trials. We're going to do groups of 5. And so we have 6 possible outcomes of how many people can have headaches. There could be nobody who has a headache. There could be one person who has a headache, or all the way down to everybody could have a headache. Those are all the only outcomes you could have. The second part is they all have to be independent events. Independent. That just means that just because the first person has a headache does not affect whether or not the second person does. If they happen to be dependent events, we can apply our 5% rule. And should put or 5% rule. Okay, that was when is the sample 5% less than 5% of the population. That doesn't happen too often. All right, the third thing we need to consider, are there only 2 possible outcomes? 2 outcomes. Outcomes. Okay, meaning that is referring to your success and your failure, or in other words, just a P and a Q. So in this case, I believe it is. We have P, which is going to equal the probability of having a headache. So this is success in this case is having a headache. So it's good to always define your P and your X. And your P and your X always go together. Here your X is actually the number of people with a headache. Okay, so it's just understanding what your different values mean. P is always a percentage. It's going to be a decimal. X is always going to be a whole number. It's a discrete random variable. So while P is your probability of having a headache, X is your number of people in the group that do in fact have a headache. And they actually give us this information in this problem right here, 0.737, 0.737. So in this case, this is MAT. These are independent events, and we do just have 2 outcomes. And number 4 is the probability of a success is the same for every trial. So P is always the same. And that is true for this problem. They don't give us more than one value of P. No matter whether you have 3 people with a headache or 5 people with a headache, the probability of having a headache is always the same, 0.737. All right, so let's take a second, and while they give us this probability, I just want to go through and make sure that you're clear on where these numbers are coming from. So let's go through our own step here. What is the probability, for example, of getting 3 headaches? I'm going to change my color here since we're doing an example. What is the probability that 3 people in our group, will have headaches? X equals 3. All right, do we remember the formula for the probability distribution form, binomial distribution formula? Binomial formula. And it's probably a good idea to write it down, have it at the top of your paper, write it every time you use it. You'll slowly start to memorize it, which is the probability that X equals whatever you want it to, some small x, equals, and choose X, P to the X, Q to the N minus X. This is all multiplied, okay? All right, so in this case, what is this? So N in this case is our 5. Always define your values. N equals 5. We know P equals 0.737. So therefore, what is Q? We're going to need to define Q for this. We need those 3 parts. So let's actually make a list. So we know N equals 5. We know P equals 0.737. We need to figure out Q, and we know X is going to equal, for this problem, we're trying to find X equals 3. All right, so what is Q? Well, if you remember before that because you only have 2 outcomes, P and Q, the probability of P plus the probability of Q is going to equal 1, always. 100%. You either have a success or you have a failure. So we just need to subtract 0.737 from 1, and we're going to discover that Q equals 0.737. 2, 6, 3. All right. All right, so we can do this on our calculator. We can plug it into the formula. We have 5, choose 3 times P, which is 0.737 to the power of 3 to the power of x, times Q, which is 0.263 to the power of 5 minus 3, which is basically your remaining 2 people. 3 people have headaches and 2 people do not. You plug that into your calculator, and sure enough, you will get 0.2769. Now, I do want to take just a second and show you how to do this with technology. If you get out your StatCrunch tips, you can put this data into StatCrunch, although you don't actually have to put it into StatCrunch. You can just open a StatCrunch tab. And if you recall, you can click, using the StatCrunch tips, you click on Stat, you open your calculator, and there is a binomial calculator that's right here for us. We put in the value of n, which in this case is a 5, and we put in the value of p, which in this case is 0.737. It will actually calculate Q for you. And then we put in our value here. For example, we were trying to find the probability that x equals, what was it? I think it was 3. We wanted to find equals 3. And then we can compute it. And sure enough, it's 0.2769, which is exactly what we have up here. So you can use technology and so on. All right. So there's the review of binomial formula, probability distributions, and how we solve problems using them. We'll start doing some of the homework assignments now. Okay, good luck.